For decades, the story we've all heard about the future of work has been pretty simple. Robots are coming for the manual jobs, while the thinking jobs, the desk work, will be safe. But what if that whole story is upside down? What if the real disruption isn't about replacing our hands, but about making our cognitive work cheap? The evidence we're going to explore today points to a really surprising future, one where physical dexterity becomes rare and valuable, while a lot of what we call knowledge work becomes abundant and maybe less valuable. And that right there, that's the core idea we're going to unpack today, a concept we'll call inverted automation. It's a really counterintuitive thought that flips a lot of our basic assumptions about jobs, skills, and value right on their head. You see, generative AI is making it incredibly cheap to produce text, code, analysis, all the symbolic stuff that desk jobs are made of. But at the exact same time, trying to automate tasks that need a delicate touch in a messy, real-world environment, well, that's still incredibly hard and incredibly expensive. This growing gap is what sets the stage for a massive economic shift. So, let's put a formal name to this and really define it. Inverted automation describes a world where those high-skill, symbolic tasks, think of analysts, programmers, writers, are actually the ones getting hit hardest by automation. And at the same time, jobs that are rich in physical contact and dexterity, everything from a master electrician to a physical therapist, prove to be super resistant to being replaced by a machine. This turns that classic economic pyramid on its head. It really challenges this long-held idea that getting a degree and working with your mind is the ultimate protection from automation. Okay, so to really get our heads around this inversion, here's how we're going to break it down. First, we're going to dig into why cognition is getting so cheap. Then we'll flip the coin and look at why physical dexterity is still so scarce. Once we've got those two pillars in place, we'll explore the huge societal shifts this could kick off. And finally, we'll build a little dashboard so you can track for yourself if this future is actually happening. So, let's dive right in with the cheapening of cognition. All right, argument one. It's all about the cheapening of cognition. And to understand this, we need to look at two things. First, the incredible power of generative AI in the world of symbols and text. But just as important, where its limits are. Its built-in structural weak spots. So much of what we call desk work lives in this purely symbolic world, right? The end products are just symbols, text, code, spreadsheets. The inputs and outputs are already digital, which means an AI can plug right into the workflow. And here's the key part. It has low physical coupling. A typo in an email draft, it doesn't cause a factory to grind to a halt. Embodied tasks, though, are a whole different ballgame. They need physical contact, delicate force control. They have to deal with the messy, unpredictable physical world. And because of that high physical coupling, a tiny error can have huge, costly consequences. This single distinction is pretty much the key to understanding where AI is heading right now. At the heart of all this, of course, is the large language model, or LLMs. And when you get right down to it, an LLM is a deceptively simple thing. You can think of it as a master guesser. It's just a machine that is incredibly good at estimating the probability of the next little piece of a word, a token, based on all the ones that came before it. Its amazing power doesn't come from understanding or consciousness. It comes from learning the statistical patterns from trillions of words of text. And that's what allows it to imitate, with frankly stunning fluency, all the different ways that humans write and code and analyze things. So why is this guessing machine so powerful? Well, this probabilistic approach gives it some incredible structural strengths. Its ability to just recognize and then replicate patterns from these massive data sets is something we've never seen before. The transformer architecture underneath it all is brilliant at keeping track of context across really long documents so it doesn't get lost. This makes it super flexible for any task that's about transforming information, summarizing it, drafting it, refining it. It is especially good at producing what you might call low-stakes first drafts. The intermediate work that takes up so much of a professional's day, which can then be handed off to a human for the final review. Okay, but the flip side of that power is a deep structural fragility, and this is so important. These aren't just bugs that will get fixed later. They are fundamental to how the technology works. An LLM is trained to make text that looks plausible, not text that is true. Its performance falls apart when it sees something weird or new that wasn't in its training data, a problem called distribution shift. It can confidently just make things up, what we call hallucinating. And maybe the biggest problem of all is the accountability gap. An LLM's perfectly fluent language hides how uncertain it actually is. And at the end of the day, you can't sue a piece of software or hold it ethically responsible for its mistakes. So, what's the takeaway from all this? It means that reliability in these systems can't just be expected. It has to be carefully, painstakingly engineered by humans through oversight and testing. The really hard stuff that's left over, that final 10% of desk work, is almost always the part where institutions absolutely demand accountability, verification, and legal liability. And that creates this huge bottleneck. It compresses the work of producing the first draft, but it massively expands the work of review, oversight, and governance. Okay, that's one half of the equation. Now let's turn to the second pillar of this whole idea, the scarcity of dexterity. While software has been taking these giant leaps, the world of physical robots has been on a much tougher, slower journey. And the reason for that isn't a lack of smarts, it's a constant, stubborn battle with the laws of physics, especially in places that aren't perfectly clean and predictable. This quote just nails the problem perfectly. The real bottleneck in robotics isn't usually about abstract intelligence or thinking. It's about the messy, unforgiving physics of touch. It's about managing friction, applying exactly the right amount of force to a delicate part, and doing it right almost 100% of the time, over and over, in a world where nothing is ever in the exact same spot twice. The physical world, unlike a Word document, doesn't have an undo button. So how can we think about this in a more structured way? Well, there's a really useful little framework for this called the screen-hand-field triad. It lets us break down any job into its three main interfaces with the world. You've got screen tasks, which are all the symbolic, computer-based parts that are super vulnerable to AI. Then you have hand tasks, the ones that need physical skill and touching real objects. And finally, you have field tasks, which are all about human interaction, building trust, and being present in a social situation. If you score a job on these three things, you did a much, much clearer picture of how easy or hard it is to actually automate. And when you apply this, the whole concept just snaps into focus. Take a report analyst. They live almost entirely on the screen. The real bottleneck for their job isn't producing the report, it's taking accountability for it and setting the goals in the first place. Now look at a precision assembler. Totally the opposite. Low screen score, but their hand score is maxed out. Their bottleneck is pure physical dexterity. And then you have a nurse. They're a mix of all three, but look at that field score. The critical, irreplaceable part of their job is building human trust, ensuring patient safety, and understanding delicate social context. These are things that are incredibly hard, maybe even impossible to fully automate. And all those bottlenecks get even bigger because of what we can call friction modifiers, the things that make real-world robots so expensive. High variability in the parts, the need for delicate force control, high stakes where a mistake could injure someone or cost millions, and the sheer difficulty of just checking if the robot did its job right. Each one of these makes the problem exponentially harder and more expensive to solve. It's why in robotics, that last 10% of the problem often takes up 90% of the time and money. Okay, so we've got cheap cognition on one side and scarce, expensive dexterity on the other. You put those two massive trends together, and what kind of world do you get? Well, that brings us to our third argument, the potential for a really deep societal inversion, looking at the huge economic and even cultural shifts that could come from this tech imbalance. This really forces us to ask the central economic question, doesn't it? If the cost of generating a first draft of just about anything, an email, a report, a marketing plan, or a piece of software, if that cost drops to almost zero, where does the value go? What skills and what tasks become the new bottlenecks, the new scarcities that the market will pay a premium for? Well, the evidence suggests that value starts to pool in at least 5 key areas. First, goal setting, simply telling the AI what to do and what success looks like. Second, verification, that critical human judgment to check if the AI's work is accurate and safe. Third, integration, the skill of designing workflows where humans and AIs actually work well together. Fourth, accountability. This is a big one. The uniquely human act of putting your name on something and taking responsibility for the outcome. And finally, those field skills we talked about, building trust, persuading people, providing care, all the on-site context that machines just don't get. Now, this shift has some really serious knock-on effects for how we build careers, creating what you could call the ladder problem. Think about it. Traditionally, you learn a profession by doing the grunt work, the routine draft work. But if AI automates a lot of that, firms might just hire fewer junior people. And the ones they do hire might get stuck in these narrow verification roles, just checking the AI's homework. The result could be a broken career ladder with way fewer chances for young talent to develop the broad experience and judgment they need to become leaders. And this could lead to one of the weirdest, most counterintuitive outcomes of all, a great decoupling of wages from cultural status. On the one hand, you could see intellectual activities, writing, analyzing, creating, retaining all their cultural prestige, maybe even becoming a status symbol, precisely because they're no longer essential for making a living. And on the other hand, you could see embodied work, from skilled trades to hands-on care, commanding a huge wage premium simply because of scarcity, even while it remains culturally undervalued. We could be heading for a future where what society pays for is totally different from what it admires. So this is a compelling story. But is it true? How would we even know if this inversion is actually taking place? Instead of just making a prediction, let's finish with a practical toolkit, a dashboard of concrete, measurable signs we can all watch to see if this thesis is holding up in the real world. This dashboard gives us a set of real early warning signals to watch. We should look at wage growth. Are plumbers' salaries growing faster than graphic designers? We should watch the hiring pyramids in big consulting and law firms. Is that ratio of junior to senior people shrinking? We can even track the mix of tasks within a job. Are people spending more time reviewing and governing and less time actually drafting? And we can compare how deeply AI is being adopted in offices versus how deeply robotics is being adopted in factories. By watching these specific things, we can cut through the hype and see if this shift is really happening. But we have to be really careful here. None of this is destiny, and measurement is hard. Just because a job can be automated doesn't mean it will be. Wages aren't just about technology. They're shaped by unions, by regulations, by policy. And a lot of companies might run pilot programs that look impressive, but real deep adoption is something else entirely. It's much more likely that if this inversion happens, it will be really uneven, powerfully true in some industries and almost non-existent in others. Heterogeneity is going to be the rule. And this all brings us to our final lingering question. This isn't just about economics or tech. It strikes right at the heart of our modern society, which for generations has prized symbolic cognitive skills above almost everything else. If the economic value of our thinking is fundamentally repriced by technology, we're forced to ask some much, much deeper questions. How will we define the value of our work? How will we measure the worth of our skills? And in a world where thinking becomes cheap, how will we build our own sense of identity and purpose?